Hydrocarbon combustion. It's the power that fuels our society. It's everywhere, in cars, boats, heaters, ovens, lighters, barbecues, tanks, modern fireplaces, and much more. My name is Steve Johnson. Welcome to Chemical Reactions 101, and today, we'll be talking about hydrocarbon combustion. First of all, what is combustion? Well, this is combustion in a nutshell. Ahem. Combustion is a type of chemical reaction that releases an incredible amount of energy as a result. Combustion needs three things to take place: oxygen, heat, and fuel. That is where hydrocarbon comes in. So, what is a hydrocarbon? Well, a hydrocarbon is a molecule made up of only hydrogen and carbon atoms, thus the name hydrocarbon. Types of hydrocarbon include methane, ethane, butane, hexane, and octane. So, where do they come from? Hydrocarbon fuel typically comes from dead dinosaurs crushed and fused under layers of rock for millions of years. They are extracted from the ground as crude oil or natural gas. There are two types of combustion: complete and incomplete. Complete is a perfect world type of combustion that takes hydrocarbons and oxygen, who react to produce only water, carbon dioxide, and a lot of energy. Unfortunately, this kind of reaction takes a lot of oxygen, and sometimes, it turns into incomplete combustion. Incomplete combustion is when there is not enough oxygen for a complete combustion, and it ends up being much suckier than complete combustion. The reaction looks a bit like this. Hydrocarbons plus insufficient oxygen reacts to form carbon dioxide, water, energy, and some extra crud like carbon solid, carbon monoxide, and unburned hydrocarbon. The products of hydrocarbon combustion can be harmful to the environment, especially those from incomplete combustion. Carbon dioxide is known to cause global warming and acid rain, while carbon monoxide and unburned hydrocarbons are lethal to living organisms in large quantities. Sometimes, nitric oxide can be released from incomplete combustion in your car. Nitric oxide is over 300 times more powerful than carbon dioxide in terms of the greenhouse effect, as well as being toxic and causing smog. Utterly disgusting. Leg. So, how can we prevent these harmful substances from entering our precious earth? We can't just stop using them. Well, one of the main polluters who use hydrocarbons are vehicles. We can't live without them. Yet. And quite a lot of people use them. The answer is catalytic converters. Catalytic converters are attached to the exhaust pipe of cars to reduce the amount of harmful substances caused by incomplete combustion released in our atmosphere. There are two kinds of catalytic converters used in a car. The reduction catalyst is used to reduce the amount of nitric oxide released. It does this by heating up metal plates, making it a catalyst for a decomposition reaction to occur. The reaction is as follows. Nitric oxide decomposes, with the help of the catalyst, into oxygen gas and nitrogen gas, both harmless to the environment. The second type of catalyst is called an oxidation catalyst. An oxidation catalyst is meant to reduce the amount of carbon monoxide and unburned hydrocarbons. It does this by both catalyzing and adding oxygen to the emissions as well. Chemical equations are as follows. For carbon monoxide plus oxygen gas reacts to form carbon dioxide in a synthesis reaction. For unburned hydrocarbons plus oxygen gas combusts to form water and carbon dioxide. Catalytic converters in cars greatly reduce the amounts of deadly chemicals spewing out thanks to incomplete combustion. Unfortunately, they still can't reduce the amount of carbon dioxide pollution, a known contributor to global warming. So it's still best to bike when you can. Join us next time, when Howder does a project on biology. Well, if we get a project on biology. I hope you learned something from this video. This is Steve, signing out.